Welcome to Financial Analytics. In today's session, we are going to discuss what is a correlation and how to get a correlation from R. Now, R has a very great visualization power because it gives 7 methods for data visualization of a scatter plot. Then there are 3 layout of a correlation matrix. Then there are 7 to 8 divergent colors, and then there are 9 to 8 sequential colors. So now what we have to understand the underlying theory behind the correlation in statistics and underlying theory of a correlation plot in RStudio. So let us start by understanding what is a correlation. Correlation is a statistical measure to measure the extent to which two variables are related, like sales and profit, how these two variables are related to each other. But businesses are not only interested in the relationship between these variables, they are also interested in knowing to what extent these variables are related to each other. Now, this relationship can be a positive, this relationship can be negative, or there can be a no relationship conditions. So let us start by understanding what is a correlation and what is the underlying theory behind a correlation plot in R. So let's go to the whiteboard. Up to this point, what we have understood, the correlation is a relationship between two variables, and there are 3 types of correlations. First is a positive correlation, second is a negative correlation, and third is a no correlation. So these are the 3 types of correlations. Now, when we can say the relationship between a positive, take one example of a sales and profit relationship. On y-axis we have a profit, and on x-axis we have a sales, and our data points are on a scatter plot are look like this. Now what this scatter plot says, as the sales of a company increases, profit increases. So the relationship is a positive because as one variable increases, other also increases. So how to interpret a positive correlation? Positive correlation is interpreted in 2 ways. As one variable increases, other also increases. Means as the sales increases, profit also increases. At the same time, as one variable, which means sales decreases, profit also decreases. So this is the interpretation of positive correlationship. Then in case of negative correlationship, the data on a scatter plot is spread like this. Now, how to interpret this negative correlation? So this is a basically negative correlation. So in sales and profit, there is a negative correlationship. So when there is a negative correlationship between two variables, we have to interpret it like this. As one variable increases, means as the sales increases, profit decreases. And oppositely, as one variable, that is a sales, decreases, profit increases. So these variables move in the opposite direction. So as the sales increases, profit decreases, and as the sales decreases, profit increases. So this is the way we can interpret the negative correlation. And there is a last correlation type is a no relationship. So the data points are scattered like this. On y-axis we have a profit, and on x-axis we have a sales, and there is no trend, or there is no relationship between sales and profit, and hence we say that there is a zero relationship between these two variables. So this is about the scatter plot. Now what we will see, how to interpret the strength of the relationship between these variables, and the strength of the relationship between these variables is given in terms of a correlation coefficient. So let's move ahead to correlation coefficient. The strength of a relationship between two variables is measured in terms of a correlation coefficient, and this correlation coefficient is given as a sign of r, and this r move in the range of -1 to 0 to 1. So the correlation coefficient measures the strength of a relationship between two variables, and this correlation coefficient lies between -1 to +1. So -1 is an indication of a very strong negative relationship, very strong negative relationship. Plus means very strong positive relationship, very strong positive relationship. And the correlation coefficient is near to 0, then we say that there is no relationship. Between 0 and -1 we have a -30, then -50. Here we have 30, 50 and 70. So accordingly, we have to interpret. If the correlation coefficient is +30 or -30, we can say that the relationship is weak. If the correlation is near +70 or near -0.70, we can say that relationship is a moderate. And the correlation coefficient beyond 0.70 up to 1, we can say that the relationship is very good or relationship is very strong. So in this way we have to interpret the correlation coefficient. So correlation coefficient lies between -1 to 0 to 1. So this is a theory behind correlation. So let us discuss the Corrplot in R package. Corrplot is a part of R package which provides exploratory tool on a correlation matrix, which find hidden pattern on data and provides the simplest methods to interpret the correlation matrix plots. Corrplot has an option in terms of visualization methods, graphical layout, colors, and legends. So let us start about the R package. Now the R package has 7 different methods for Corrplot visualization. The first method is a number, second method is a circle, third method is a square, fourth method is ellipse, then shade, color, and pie. So there are 7 methods for data visualization. Let us start with the first method, that is a number. The number method in Corrplot returns the coefficient numbers with the different colors. So now you can see bar chart or bar here, and which has a range from -1 to +1, and there is here we can find a 0. Now we know that the -1 indicate very negative correlation, 0 indicate no relation, and +1 indicate strong positive association between two variables. And in this plot you can find numbers with different colors. Now this is a diagonal, and you can find on this diagonal number 1. Why we find this number 1 on this entire diagonal? Because it is a relationship of a variable with itself. For example, the correlation between income with itself become 1, the correlation coefficient of a cost with itself become a 1. So in this way you can interpret these correlation coefficient on this diagonal. And if you can see, the color is a very dark blue for this diagonal because the number is a positive one. And if you see here, the color is very dark for blue for the number 1. Now if we start from here, from 0 to 1, you can find the color is becoming more and more darker as we go to positive 1. So at +1 or at positive 1, the blue color is a darker. Similarly, you can also find as we start to go down from the 0, the pink color is becoming more and more and more darker at a -1. So this suggests that if your correlation coefficient is beyond 0.70, the color will be very, very dark. Similarly, if your correlation coefficient is beyond 0.70, the color will be dark blue. We can find in this correlation coefficient, the correlation coefficient is a 0.87, and 0.87 is a close to 1. So you can find a very dark blue color for this correlation coefficient. Similarly, the correlation coefficient between income and the equity is a 0.93, and here also you can find a dark blue color. Now if you find in this region, the correlation coefficient is a half to 1, that is a 0.50. So the color is a very lighter, and you can find the colors for 0.50 in this region. So 0.51, 0.52, 0.43, 0.52, and 0.53. So for all these 5 numbers, the color is a very light blue. Now the most interesting part is this. The correlation coefficient is a -0.18. Now for a -0.18, the range is this, and the color is very, very light, and the color is a pink. So the number is not visible to us, and we can interpret this that if the number is not visible, which means that the correlation coefficient is a very weak, and the color is in a very light pink, that is the indication of a relationship is a negative. Now how to interpret the correlation coefficients? Now the first correlation is between income and income. As I had discussed, on this diagonal you can find only one value because this is a correlation of a variable with itself. So income is associated with the income, and the correlation coefficient is a 1. Now when we reach at this point, the correlation coefficient is a 0.96. The correlation is a positive, and the correlation is very strong because the correlation is near to 1. Now how to interpret this correlation in a finance? The income and cost is positively related, and the relationship is very strong. This suggests that as income increases, cost also increases, and we are studying the Maruti Suzuki data. Now how to interpret this correlation coefficient? As the income or revenue of Maruti Suzuki increases, the production cost, labor cost, and other expenses are said to increase. So income and cost are very strongly related, and this is obvious. Now if we find this correlation, income and interest are positively related, but the relationship is weak because the correlation coefficient is a 0.45. So this is a very weak or moderate correlation. And this is obvious because income and interest are not related, but debt and interest are related actually. So we do not have to interpret this correlation coefficient, but the most important part is a income and a profit. How income and profit are related. Income and profit are positively related, and the number 0.87 correlation coefficient is close to 1. So this suggests that as the revenue of the company, as the revenue of Maruti Suzuki increases, profit is also increases. So accordingly, you can interpret for the rest variables. Now, the next method is a circle. Now, how we interpret the circle in terms of a correlation coefficient, the the areas of the circle shows the absolute value of corresponding correlation coefficient. Now, if we find out the diagonal where we can have a positive one value that we have discussed in the previous slide. So on this diagonal, we have +1 value. So the color is a very dark and circle is a full. But if you go to here, the correlation between interest and income in previous slide we have discussed is a 0.45. So the circle is a small as compared to the all these circles. This circle is a small, and the color of this circle is a light blue. And for this 0.45, the color will is in this range. So accordingly we have to interpret. So in the circle we have to interpret the absolute value in terms of size of the circle. As the size of the circle is a large, the correlation coefficient is a large. As the size of a circle becoming a smaller, the correlation coefficient is a weak. So similarly, you can find in this range, the circle is a very small, and the correlation coefficient is a -0.18. So the color is very lighter. You can see in this range, the color is a lighter for -0.18. So that's why we can find a very small size circle and the color is a lighter pink. So this is the way you have to interpret the circle. So we have to interpret the circle on the basis of the size of the circle. So the size of the circle indicate the area or the value of a correlation coefficient. Similarly, similar to the circle, we have to interpret the squares. The area of a square shows the absolute value of a corresponding correlation coefficient. So you can find in this range the full square, and the size as color of a square is a dark blue. So it indicates that here the correlation coefficient is a +1. Now in this area you can find the color is a dark blue, so obviously this correlation coefficient is a high, and the blue color indicate the correlation coefficient is a positive. Here you can see the correlation coefficient is a moderate because the color is a light blue and the square is very small as compared to these colors or these squares. So the size of the square is small and the color is a light blue. So we can interpret this as the correlation coefficient is in this range, nearly 0.50. And these pink color squares indicate that the correlation coefficient is negative, and the size of a square is half, and this square is empty. You can find here the white space which is empty, so that we can interpret that on these squares the correlation coefficient is a moderate one. So accordingly we can interpret this square. So when we have a color method that we will use, the color correlation plot is is equal in size but have different colors. So the size are equal, but the correlation coefficient is represented with the different colors. For example, you can find here the correlation coefficient is a +1 and the color is a darker. In this range, the color is a darker, which means the correlation coefficient is a near +1. Now in this range, you can find very light color and it is in a pink color. So obviously here the correlation coefficient is a negative, and the color is very light. So the correlation coefficient is a weak. Here you can find the correlation coefficient is in or red color or pink color. So the correlation coefficient in this range and here the correlation coefficient is a negative, but the color is not a darker, color is a very light. So you can interpret the correlation coefficient is a negative and the coefficient is a moderate. It may be in the range of 0.50 to 0.60. Now the coming to the next method, that is ellipse. Now the ellipse is entirely opposite to all the earlier ones. So in ellipse you can find a straight line on the diagonal, and we know on the diagonal we have a plus value. Now here you can find a round color ellipse and the color is a light. So it indicates that the correlation coefficient is a moderate. Why it is a moderate? Because we have learned on this diagonal, if the correlation is a near to 1, it is a straight line. But if it is a round and it has a light color, so the correlation coefficient is a weak. So the more the round color, the weaker the correlation coefficient or lower the correlation coefficient. If you find the correlation coefficient higher in this range, because these are not wider circles, these are almost similar to a straight line but not a straight line. So you can find here the stronger correlation coefficient. Accordingly, correlation coefficient need to be interpreted. So in ellipse, if we find a straight line, we have to interpret it as a stronger correlation coefficient. And if it is a blue, means it is a positive. If it is in a pink color or red color, it is in a negative. And the more the wider and the more the round, the weaker the correlation coefficient. Now coming to the shades. Now in shades are similar to color method. There is nothing different or separate to understand. There we have to interpret the correlation coefficient as per the color. So more the dark blue, you can say the stronger is the correlation coefficient. Here you can find the darker blue color. There is a strong correlation coefficient, a strong correlation between two variables. So the income and cost are strongly related. You can find here the light blue color. So we can say that income and the interest are weakly related or moderately related. Now here the color is a dark. So we can say that the variable income is a strongly and the color is a blue. So positively strongly related with the profit. Now you can find here a light pink color. So you can say that the color is a pink. So there is a negative relationship between these variables, and hence the negative correlation as well as the correlation is a moderate because the color is a lighter. So in this way, we can interpret these colors and shades. Now coming to pi method. These pies are filled clockwise for positive values. So these are positive values So they are filled clockwise, and in a negative values in this area, in the negative values, they are filled anti-clockwise. So they are filled anti-clockwise. Here you can see. So in this way they are filled anti-clockwise. Here you can see they are filled anti-clockwise. So accordingly we have to interpret the correlation coefficient. Now here you can find the, in this case we will discuss first this case. Now the this pi is filled in this way clockwise, and the area which is empty, that is a very small. So we can say that the color is a very darker and the empty space is a very small. The correlation coefficient is very high. Now coming to this pie chart. Now this is a pie chart which is negatively related, or this has a negative correlation coefficient because the color is a pink and they are filled anti-clockwise. So only this small area of this entire circle is a field. So we can say that the correlation coefficient is a weak between depth and fixed asset. So again we can see here the correlation coefficient between interest and debt is a very small because it is in pink color and the area filled of this entire circle is a very small. So accordingly we can interpret the correlation coefficient on the basis of a pi method. Now let's try to understand correlation matrix layout. So there are methods that we have learned, and now we are learning the matrix layout. So there are three methods of a correlation matrix layout: the full method, then lower method, and then we have a upper method. Then next, first try to understand what is a full layout. Now this is a diagonal, and on this diagonal, let's 1 minute. So this is basically our diagonal, and let me draw it so you can better understand. So this is our diagonal, and on this diagonal, this area, this entire area is a mirror image of this lower part. So this is our diagonal, and this is our upper part, and this is our lower part. Now this upper image is a mirror image of this lower matrix. Next, so this is about the full layout method. So in full layout we get the lower part as well as the upper part. Now coming to the upper part. So in upper part we only get this portion. We get only this portion. So this is the full layout which include the upper part as well as a lower part. So upper part is what? It is a mirror image of a lower part. And what is this lower part? Lower part is a mirror image of a upper part. So we can show a correlation matrix in terms of this full layout, or we can show in terms of the upper layout, or we can only show the lower part. So this is about the correlation matrix layout. So try to remember correlation matrix layout, or there are three methods: full method, lower method, and upper method. In full method or full layout, you can find the upper part as well as a lower part, and we can show only in we can show correlation matrix as a layout in terms of upper as well as a lower. So lower is basically a mirror image of this upper part. And what is this upper part? Upper part is the mirror image of the lower part or lower layout. So let's move ahead to the R2. For correlation analysis, we are going to use these three packages: library Corrplot, then library R color brewer, and library psych. But I have given the comments to it because initially I want to use a basic functions which are available with the base package in R. And once we use these functions of a correlation in the base package, then we will use these libraries. So I have a data of a Maruti Suzuki, which I have imported in the R. And this is the data of a Maruti Suzuki. Let's check the head of Maruti Suzuki. And we can see here, this is in a table format. The data of Maruti Suzuki is in a table format, and there are 8 columns. So financial year is my first column, then income is my second column, then cost, interest, profit, equity, debt, and financial assets. And the income is in terms of rupees. It is almost 83,000 crore rupees, the sales for 2021. And similarly, you can interpret these figures. So we have 8 columns, but out of these 8 columns, we do not require financial year during correlation analysis. So we have to clean this data and we have to remove this column when we are going to do correlation. So we have 7 financial variables: income, cost, interest, profit, equity, debt, and fixed asset. Now this is a data related to Maruti Suzuki. Now I want to check the internal structure of a Maruti Suzuki. So I will simply write, give me a structure of a Maruti Suzuki, and we have this internal structure. The data is in a table format. The data has 15 rows, 8 columns, and these columns are this: financial year, income, cost, interest, profit, equity, debt, and fixed asset. Now the rows are 15. That indicates the data has 15 years. Now this data basically commences from 2007 and end at 2021. So this data is basically of 15 years. Now let's start to clean this data. And why we need to clean this data? Because we do not want the first column, that is a financial year. So first we will create one new table or data frame, and we will assign it a name that is MS, and we will delete a first column. Now this is a square, and in the square I'm writing -1. This -1 indicate that -1 after comma indicate that delete a first column and give me remaining data in the variable MS. And now I can have a data in the MS which has a first column income, and hence we have removed a financial year column. So now our data is almost ready for a correlation. Now if I want a correlation, I will write, give me a core. So core means a correlation. This is a function in R or in base package in R. For a correlation, we have a core function, and give me a core of MS. And I am giving a variable correlation. Whatever is a correlation matrix will be recorded in this correlation variable. So now our correlation matrix is ready, and if we want to see where is a correlation matrix, then go to this environment, and in this environment you can see here the correlation. Once I click on it, the correlation matrix is available. Now all these are the correlation coefficient. Let's move ahead. Now here I write correlation. It will return me a correlation. Now these are the correlations. Correlation of income with itself is always 1. The correlation of cost is always 1 with this cost. Now we can interpret this correlation coefficient column wise. The income has a first correlation coefficient is 1 because income is correlated with the 1. Now the income and cost has a correlation coefficient of 0.96. The correlation is a positive, and the 0.96 is very close to 1. So we can say that income and cost are strongly related with each other. And then here we are interested basically because we are interested what are the factors which influence the profit. Now how income and profit are related? Income and profit in Maruti Suzuki are positively related, and the number 0.86 is very close to 1. So we can say that income and profit are strongly correlated to each other. And now how to interpret this correlation coefficient? As the income increases, profit increases. At the same time, as the income decreases, profit also decreases. Now we also have one negative correlation coefficient. The income and debt is negatively correlated. You can see here the negative sign. So income and debt are negatively related with each other, and the correlation coefficient is a minus 0.52. So minus 0.52 indicate that the correlation between income and debt is a moderate. And how to interpret this relationship? As the income of Maruti Suzuki increases, the debt declines. So how it happens? Because as the income increases, the profit also increases. Out of profit, company pays a dividend, and also company pays a royalty, and the rest amount is used as a retained earnings. And so the company does not need a debt. So as a company is highly profitable, so they prefer to use that retained earnings. So that's why we can find the income and debt are negatively related with each other. So let's move ahead. Now if I want only this column, profit, because we are interested in knowing the factors which are affecting the profit. So we are interested in this column, profit. So what we will do, we will only bring this column only, because this is a correlation coefficient for all the variables. But we are only interested in the profit column. So let us check how to do that. Now I will write a core. Give me a correlation of ms and square bracket, and I'm closing a bracket. So that indicate give me all the columns, give me all the 7 columns, and correlate it with ms. Ms has a profit variable, profit, and then write, give a single or double quote, and my ms is small, so it's a mistake. Now my correlation is ready, and now you can find here this is the only column of profit. The profit and income are positively related, so income is a key important factor which influence or which strongly related with the profit. cost is also related to the profit, and this is obvious. As income increases, cost also increases, and as income is related to the profit, cost is expected to relate to profit. Now, profit and interest are moderately related. Profit with itself is obviously strongly related, because profit is related to profit, so the correlation coefficient is a 1. the the relationship between profit and equity is a positive. Then the relationship between profit and debt is a negative, that we have discussed. And the relationship between profit and fixed asset is a positive, and it is a moderate. So 0.52 correlation coefficient is a moderate. So now let's move ahead. Now there only one thing is remaining. If you can see here, the correlation coefficient have almost 7 digits. Now what I want to round it, so make it easy to read and understand. So write correlation, which is my variable, and I want two numbers after 0, and you can see here there are only 2 decimal points after 0. So now it is very easy and convenient to read and interpret these numbers as compared to the 7 digits. So now let's move ahead. Now what we will do a correlation test. Now for the correlation test, we have to write a core and then core test of 2 variables. MS has an income and cost. We want to check how income and cost are correlated to each other, and whether this relationship is a statistically significant or not. Now what we can see here, the correlation coefficient between income and cost is a 0.96, and this correlation coefficient is a statistically significant because the p-value is less than 0.05. So that is the interpretation of a correlation test. Now let's move ahead. Now what we will do, we need these libraries. So I am commenting out and I am installing these 2 libraries. The first library is a library Corrplot, and the second library is a library color beaver. Then I have installed these libraries, and now let's move ahead. Now our data is in the variable MS, and we have installed library Corrplot. So if I want a Corrplot, I will write a Corrplot. Give me a Corrplot of MS. Now when I write this Corrplot of MS, the error will come. The matrix is not in a -1 format. So basically the problem is that our MS is in a table format, and when we are using a Corrplot, we have to convert compulsory the MS table format to MS in a matrix format. So our data must be in a matrix format. So table and a data frame is not accepted in a Corrplot library. So if we want to use a Corrplot, we have to convert our data into a matrix form. So what we will do, we will create a new table or new matrix that will store our MS data or Maruti Suzuki data. So as dot matrix and MS. So my entire data is in MS, and now what I am doing, I am converting that MS, which is in a table format, I am converting it into the matrix, and then I am assigning that entire data to this MS1 variable. And now my data is ready, and if I check the MS1, Now this my MS1 is in a matrix format. So if I check its class of MS1, the class of MS1 is a matrix and array. Now the next stage is we have our data into MS1, which is in a matrix format. Now we have to again run the correlation on MS1 because our data is in a matrix format that we have just did, and we need a correlation matrix in the matrix format. So what I am doing, I am writing a core2. And what is this core2? This core2 will store a correlation matrix that we have created in a MS1 of MS1. So core2, and then give me a correlation of MS1. What is this MS1? The MS1 is a Maruti Suzuki data that we have created in a matrix format. So my core2 is ready, and this is a core2 that you can see in a global environment. What is this core2? Core2 has stored the correlation matrix, and you can see the correlation matrix. Now we are moving ahead. Why we are doing these stages? Because our data in earlier, our data is in a table format, and we are using a library Corrplot, and Corrplot wants the data in a matrix format. So what we have done, we have transformed our table data into a matrix format and then stored it in a MS1, and then we use this core2 variable to store a correlation matrix of a MS1. So now we are ready to use a Corrplot functions. Now if I want a Corrplot, I will write a Corrplot, and I will write down here core2. Now what is a core2? Core2 is a correlation matrix. Now you can see here, let me make it large. Now you can see here the correlation plot. This is basically in a method circle. Now in a correlation plot, you have to mention the methods, what methods you are using. Now you can see here, there you can check in Corrplot, there are 7 methods that we have discussed. So this is a circle method. When we write Corrplot of a core2, the default method is a color. Now if I want a numbers, then I have to mention my method Corrplot, and then core2, and then if I mention a method of a number, and then it will give me a number method. Now this is a correlation plot as per the number method. Then there are other methods. Corrplot give me core2, and then my method is a color, and this is a color method. Then next is a Corrplot, give me a correlation to where the method is, where my method is shade, and now you can see the shades are given to a negative numbers. So there are these methods. Apart from these method, there is a one method that is a pi. So method is equal to pi. Now you can see here the pi Corrplot. Apart from core method, pi method, we also have another method that is a ellipse. That is a ellipse. Now you can see the ellipse method. Now what we will do, we will try to change the background. So Corrplot, Core2, the method is number, and BG stands for a background, and give me a gold background. And now you can see the background is changed, and now it is a very lucrative to visualize and to understand. Apart from this background color, we can also use a layout. We can also use a layout. And now how many layouts are there? There are 3 layouts. So what I will do, I will just copy this code. I will copy this code and paste it here, and simply write, give me a type of full. Rather than full, I will start from the lower. So this is a lower layout, and similar to this lower, I'm copying and paste it here. Lower, I can write it, give me the upper part. Now the correlation matrix is in a upper format, and I can check the correlation matrix in a full format. Now when I use a full function, then I'm getting a lower part of a correlation matrix as well as the upper part of the correlation matrix. So these are the 3 types. Apart from these 3 types, you can change the methods. You can change the method from color or shade or pie or ellipse, and then you can change the type, lower, upper, or full. So there is a lot of combination that you can make as per your requirement. So we have finished methods, then type, and how to give a background. So there is one part also remaining, that is a order. So what we want to give order. So write down Corrplot, core2, then method is equal to number, give double quote or single quote, and then write down order. In order we have alphabet order, and when you write give me the alphabet order, here I have given the order is my alphabet, and here you can see the variables, the financial variables are ordered in alphabet. So first is a C, that is a cost, then D, debt, E, equity, F, fixed asset, I, income, I, interest, and P for profit. So in this way, you can also change the order. Apart from this order, alphabet order, we also can arrange our order in terms of angle of eigenvector. So now you can see here the order is changed, and I'm writing here, give me a type only lower. Now you can see the financial variables, these correlation coefficients are ordered as per the angle of a eigenvector. Similarly to this method, we can also change order. Rather than AOU, we can make it their clusters. So H cluster is a method. Now you can see here, there is a cluster. Now you can see this area. In this area, you can see the +1, 0.74, 0.93, 0.82, 0.87. The numbers are very close to 1. So what R has done in H cluster method, it create a cluster of financial variables which has a very strong correlations, and it create a group in this area. Now you can check this area where the correlation coefficient is a moderate. So this is a second cluster, and this is a third cluster which has a very negative and moderate correlation coefficients. So in this way, these orders can be interpreted. Apart from this library Corrplot, we also have one library, that is a psych, and this library will also help us to get a correlation. So for library psych, we have to write pairs, give me a pairs and dot panels of a data of MS, because in MS we have stored our Maruti Suzuki data. So I am writing that variable MS, and you can see a change in a chart or plot. On this diagonal, you can find the histogram. This histogram is basically of income. So if I have an income column of a Maruti Suzuki, so it creates a histogram of income. This is a histogram of a cost, and this is the histogram of interest. So in this way, the histograms you can see on a diagonal, and these are the correlation coefficients. On this part, you can see a scatter plot. Now, what is this scatter plot? This scatter plot is between income and cost. Now, what is this? This is a scatter plot between income and interest. So this scatter plot represent income and interest. Now, what is this last scatter plot? This scatter plot represent the column, that is the income. This is the income column, and on the row you can find here the fixed asset. So this scatter plot represent income and fixed asset, and on this upper area you can find the correlation coefficients. Now if we want to find out which correlation coefficient are statistically significant, then simply do stars is equal to true, and now you can see a change. Now you can see the first variable of income is a statistically significant. This statistically significant is related to this cost. Now income and interest, this is the correlation coefficient represent to interest, because you can see here the interest. So income and interest are not statistically significant, and the correlation is not is moderate. Now this 0.87 correlation coefficient represent to income, and you can find here the profit. So this is a correlation coefficient between income and the profit. So 0.87 correlation coefficient between income and profit is a statistically significant. So in this way, you can interpret the correlation coefficient. So in this way, we have used library Corrplot, library R-color and library psych. So you can modify your correlation coefficient, your correlation plots as per your requirement. Basically, these correlation plots are very good to visualize as well as the presentation in our report or in our papers. So let's make it practice and make it more useful, and let's make it another video. Then we will study regression. Then we again revisit this part. So thank you.